Hi, Mr. Thompson here with another math video lesson. This one on multiplying and dividing algebraic fractions. So that's what we're doing. Here we go. As we do this, we're just going to do this through examples. There's a couple of simple steps, so we're just going to start straight with an example. So here's a couple of algebraic fractions that we are going to multiply. Okay. Now, multiplying fractions, all rules of multiplying fractions apply. So if you remember how to multiply simple basic fractions, it's just the top times the top and the bottom times the bottom. Numerators get multiplied together, denominators get multiplied together. That is what we're going to do, but we need to clean this up a little bit first. We're going to simplify. So the first step is to cancel common factors from numerator and denominator. So if you look across the whole problem, hello, we're getting a little ahead, that's okay. You look across the whole problem, all the numerators and all the denominators, and look for common factors. So for example, if you were paying attention, you saw the two x's, and I've put them both in blue to be helpful here. So we have an x in this numerator and an x in that denominator. It doesn't matter that they're parts of different fractions, we can cancel both of those out, okay? When we cancel, when we take something that's the same on the top and the bottom, if everything goes away, then we're left with ones, right? They turn into ones. Now, neither of these ones are really necessary because we know 3 times 1 is 1, and 9 times 1 is, 3 times 1 is 3, and 9 times 1 is 9, right? So I'm actually just going to erase those ones. We don't need them. We might, it's something to think about though, whether or not the 1 needs to stay, so we'll see that in a second. Okay, the 3 and the 9, those are not the same, but they can be canceled because 3 goes into 9, right? But 3 goes into 3, and 3 goes into 9, right? It could have been like a 12 and a 9 or something like that, and 3 goes into both of them. In this case, the 3 cancels out. We're going to put there's a 1 that goes where the 3 is because 3 divided by 3 is 1, and 9 divided by 3 is 3. So this 3 becomes a 1. This 9 becomes a 3. And in this case, we are going to leave that 1 because there's nothing left on the top of that fraction. So we're just going to leave that 1 there. I'm not going to erase it. And I have to leave the 3 because you can't just cross out a 3. Now I'm going to look at the 2 and the 4. Very similar. I maybe should have made these a little bit different. That's all right. We got 2 and the 4. They cancel out. The 2 is going to become a 1, but there's that z there. So we don't actually need the 1. But that 4 is going to become a 2, right, when we cancel out. 4 divided by 2 is 2. 2 divided by 2 is 1, but we don't need the 1, as we said. Now, the only things we haven't really touched are the z and the y, but they're different, and there's no other z or z, there's no other y. And let's just check, look, if we look at the 2, there's no 2's or anything left that's divisible by 2 on top, and there's a 3 down here, and there's nothing that's divisible by 3 either in the rest of the problem. So we have canceled all the common factors from the numerators and denominators. We've done that first step. The second step is to multiply the numerators together, the numerators times numerators, and denominators times denominators. Right? So in the numerator, all we have is a 1, that's all that's left up here, and then a z over here, z. So that just leaves the z, right? And then on the bottom, we just have the 2 and the 3, which is a 6, but we also have the y, so it's going to be 6y. So z over 6y is our answer for this problem. Done. Let's do another example of multiplying, and then we'll look at division. All right, so example 2 is going to be 2y over the quantity x minus 3 times the quantity 2x plus 1 times x minus 3 all over y. Bit of a mouthful. Now, again, I've color-coded to help. Textbook problems are not going to color-code for you. You're going to have to notice some of these similarities. But the x minus 3 and this x minus 3, one is on the top and one is on the bottom. Okay, this one maybe looks a little different because it doesn't have brackets, but anything at the top of a fraction, anything that's on the top of a fraction, you can effectively put brackets on. Okay, so we can sort of have some imaginary brackets there, and that then those two quantities are going to cancel. They're going to leave ones, right? We want to keep this one up here because it's all that's left at the top of that fraction. This other one down here, though, we can get rid of, okay, because we're just multiplying it by this 2x plus 1. It doesn't change anything. All right, next up, you may notice the y's, the purple y's. Those can cancel. We can put 1s there. We don't need that 1 at the top because it's got the 2. And now we'll notice that we're just doing 2 times 1, and then this 2x plus 1 times 1. So pretty simple. It's just that you basically can cross this one out on the right and write down everything that's left here. Check that there again. When you're done, it's still good to check because you might have missed something. So we'll look and say, okay, are there any common factors? Well, we got 2 and 2, but we have to have a common factor for everything on the bottom, including this 1. And so this 1 doesn't divide evenly by 2. So the 2's look like they can cancel, but they can't in this case. All right, so that's done. All right, let's move on to dividing. Okay. Dividing algebraic fractions. So there is one really very important step here. Okay, so let's first get an example. Write this down. 4xz over 9 divided by 2z over 3x. All right, simple enough. Now, step number 1, super important. We need to, we basically don't divide fractions, right? In order to divide fractions, we switch it to a multiplication problem. So we're going to change the multiplication to division, other way around. Change the division to multiplication and write the second fraction as its reciprocal. Okay, so what does that mean? Well, we'll get there in a second. First, we're not doing anything to this first fraction, so we're just going to rewrite that first fraction. We're not going to change it at all in this first step. We're changing the division to multiplication as suggested in the rule. And then we are writing the second fraction as the reciprocal, which means we flip the numerator and denominator. We swap them. We flip the fraction over. My colleague Steve likes to say flipping times. Shout out to you, Steve. Steve Scotty. All right, so we're going to write this as 3x over 2z. All right, and now the next step is literally just multiply as usual. Okay, and I've underlined the word second here because it is important. One thing people ask, do we flip the first one? Do we ever flip the first one? And no, we never flip the first one. We always and only flip the second one. We only write the second fraction as its reciprocal. Okay, now we go back to our multiplication like a few minutes ago. Okay, so we're going to look for common terms like the two z's or z's or whatever we want to say. Okay. Those are going to go away. We don't need to replace them with 1s because there's other stuff. The 4 and the 2 are going to cancel. The 4 is going to turn into a 2, and the 2 is going to turn into a 1. I'm going to leave that one because there's nothing else on the bottom of that fraction. Or since it's the bottom of the fraction, I can actually just kind of forget that it's a fraction. But we'll keep going. The 3 and the 9 cancel. The 3 becomes a 1, which I don't need, and the 9 becomes a 3. Right? And is there anything else? No, the two x's, there are two x's here, both my nice blue x's, but they are both on the top. We can only cancel from top to bottom. So if two things are on the top, they have to both stay. All right, and we're going to multiply top times top and bottom times bottom. So up here we have 2 times x, okay, and x times x is x squared, and of course I need my 2. And sorry for a sloppy 2, just wrote that in with my finger because I realized I forgot it before. And then on the bottom, 3 times 1 is 3. So that is our new denominator, and that problem is done. There are no common factors anymore. It's as simple as it's going to get. All right, if you have any particular problems, as always, if you want to see more examples, just let me know. Happy to oblige. That's it for today, though. Talk to you next time.